Isn't it 4x1 plus 2x2? I am able to tell that because these are the numbers which we have entered. See, these come from the constraints. The first constraint we have to enter here. Okay, second constraint we have to enter in the second row. Okay. Is it clear?
Yes, madam.
I will erase it. Okay. See here, objective should be written on the top and constraints will come below. Okay. Yes?
Yes, madam.
Yeah. Yes. Okay. So now these are the constraints. Is the constraints clear? Can you see this and tell me the constraints? 4x1
plus 2x2 plus s1 plus
equal to, no, s2 is not there in the first constraint, so 0s2 equal to 60, isn't it? Second constraint is 2x1 plus 4x2 plus s2 equal to 48, isn't it? Yes.
Yes.
Yeah. And s1's contribution is 0. S2's contribution is 0. This we have to take it from the objective function. Is that clear from here? Yeah. Yes. Is it clear? Can I go ahead with the
second constraint, right side value 40 or 48, madam?
48 only, sir.
40. In the above matrices, it is
48,
yeah.
sir.
Yeah,
there are some typing mistakes, sir, in the material.
Yeah. Yes.
Okay. Yeah. Now you see here, we have to calculate the ZJ value. I will tell you how to calculate the ZJ value. ZJ is nothing but 4 into 0 plus 2 into 0. 4 into 0 plus 2 into 0 is how much?
0.
0. Then 2 into 0 plus 4 into 0.
0.
Then 1 into 0 plus 0 into 0.
0.
Yeah. 0 into 0 plus 1 into 0 is how much?
0.
This type of problem where all the constraints are less than or equal to constraint, in the initial table you will have all zeros. Okay. In the other greater than or equal to constraints, you will have some values. Okay, we'll come to it later. Okay, is the 0 clear?
Yes, madam.
Yes. Then we have Cj minus Zj. See, we have written it all nicely in the table so that it is easy for us to calculate. Okay. So Cj is here on the top. Zj just now we have calculated. You just subtract. 8 minus 0 is how much? 8. 6 minus 0 is?
6.
0 minus 0 is?
0.
0. Right? Is it clear?
Yes, madam.
I will tell you how to create this table. We have to write the objective function here. First we have to write all the variables. x1, x2, s1, s2. This will continue for the rest of the tables also. Then you have to write both the constraints here. Okay. Then you have to calculate Zj. Then you have to calculate Cj minus Zj. These are the steps. Okay. Yes?
Yes, madam.
Okay. Then what is the objective function? Is it maximization or minimization?
Maximization.
Maximization. In case of maximization problem, our entering variable, I'll come again. If the objective is maximize, then entering variable EV will be the maximum Cj minus Zj. Which is the maximum value?
8.
So, are you seeing the entering value here?
Yes, madam.
Yes. So, that's why the maximum, if the objective is maximization, entering value will be maximum value, maximum positive value. Is that clear? See, here he has given the rule. Highest positive value of Cj minus Zj is the ED. Is it clear?
Yes, madam.
So, one variable will enter the table. For the next table, there will be one variable which will be entering the table and there will be one variable which will be leaving us. Okay. Are you getting the point?
Yes, madam.
See, to begin with, we have begun the problem with S1 and S2, isn't it? We have begun the problem with S1 and S2. Now in the next table, you don't have S1 or S2. You will have X1 instead. X1 will be entering. Is that clear? This is the entering variable. What is this known as? Entering variable. Entering variable. So this column is known as key column. This column is known as key column. So now what we do is we divide this value 60 divided by 4. 60 divided by 4 is how much?
15.
15. 48 divided by 2 is how much?
24.
24. RR is known as replacement ratio. What is it known as? Replacement ratio. Replacement ratio. So whichever is least replacement ratio, that will become the key row. What is it known as?
Key row.
Key row. So this is the key row. So this condition is same irrespective of maximization or minimization. I'll come again. I will write down the rules here. For maximization problem, the entering value will be maximum value. Okay. What is the entering value? For maximization problem, EV will be highest positive. Highest positive. If the objective function is minimized, EV will be least negative. Least, highest negative number. Or okay, the least negative number. Okay. But replacement ratio, whatever may be the objective be, the value is least. We should take the lowest one. Okay, is that clear?
Yes, ma'am.
Yes. Lowest positive you should have to take. Not only lowest, lowest positive. Okay. So now what is the key row? First row.
S1.
Yeah, S1. So S1 will be leaving us and X1 will be entering. Okay. Is that clear?
Yes, madam.
In the next table, you will have X1 instead of S1. You will have X1 instead of S1. Is that clear? And all these values will also be changed. All these values will also be changed. Now, which is the key row? First row or second row?
First row.
First row. Okay. So now, for new key row values are quite simple to find out. Okay, I'll tell you how to find out. You can find out here. Whatever I'm writing on the screen, is it visible to you all?
Yes, madam. Yes.
Yeah. Now, I'll tell you, what are the old values of key row? Can you tell me old values of key row?
4.
Yeah.
2.
4.
1.
No, you have to take inclusive of 60. All the values.
Yeah.
60, 4, 2, 1, 0, isn't it?
Yes, madam.
We have one more term I got to introduce. Which is the key column? First column or second column?
X1 column. First
X1
one.
column. What is the key row?
First row. S1 row.
Right. So intersection of S1 row and X1 row, isn't it this value?
Key element.
Yeah, that is known as key element. Okay. So the new values of key row, we just have to divide the old values with the key element. 60 divided by 4 is how much?
15.
15. 4 divided by 4 is?
1.
1. 2 divided by 4 is?
1 by 2.
Yeah. 1 divided by 4 is?
1 by 4 as it is.
0 divided by 4 is?
0.
0. These are the new values of the first row. These are the new values of the first row. Is the new values of key row clear?
And 0 also we have to replace with 8, madam. CB column.
Yes.
CB column.
Yes, sir. Yes, sir. Yes. We have to replace the variable along with the contribution, sir.
Yes.
Okay. Now, the new values of the non-key row, I will tell you how to find out. Okay. So, key column value is 2. Key column value is what? 2. Isn't it? For the second row, what is the key column value?
2.
2. So what you do is, new key row values, you multiply all the values with 2, 2, 2, 2. Key column value multiplied by new key row values. Can you tell me the answer? 30? 30?
18, madam.
No, sir, 30. 15 into 2, 30. Don't see the material, sir. They have done it wrong.
No, I'm telling the value at 48.
Yes, sir. I'll tell you how did you get that 18. I will tell you, sir.
Okay.
Yes. See, sir. For second row, what is the key column value? 2. What is the key column value? How much is the key column value?
2, madam.
2. Now you multiply 2 with the new key row values. What are the new key row values?
15, 1, 1 by 2, 1 by 4.
0. Right? So you
Yes.
multiply all the values with 2, 2, 2, 2. Tell me the values.
Yes, 30.
2. 1.
30, 1.
Yeah. 1 by 2. 0, isn't it?
Yes.
Yeah. Now, what are the old values of the non-key row? 48.
48.
Yeah. 2.
4, 0, 1.
0, 1. Now, whatever you have got, subtract it from the old values, you will get the new values. Are you getting the point? 48 minus 30 is how much?
18.
18. 2 minus 2?
0.
4 minus 1?
3.
0 minus half?
Minus half.
Minus half. 0 minus half is minus half, right? Then 1 minus 0?
1.
1. Is it 1 or 0? Yeah, 1 minus 0 is 1, isn't it?
Yes.
Yeah. So these are the new values. Are you getting the point? See, first thing you find out the new key row values, then multiply it with the key column value, subtract this product from the old key row value, old non-key row values. You will get the new values. Is that clear? I'll show you the next table, then you will understand. See, in the next table, S1 is replaced with X1. Yes. X1, isn't it replaced with S1, X1?
Yes.
Yes. And these are the new values. Found out 60 divided by 4 divided by 4. Didn't we find out these values?
Yes, madam.
Yes. And didn't we find out 1803 minus half 1 just now?
Yes.
I will show you these values. We have just now found out. Yeah. Are we not getting the same values? 48 minus 30 is 18.
Yes, same.
Yes, same values. Okay, so here they have given it little wrong. Actually, this should be 14 minus 2 into 15. This should be like this. Okay. So bracket is little given wrong. Okay. Are you getting the point?
Yes, madam.
It should be 48 minus 2 into 15. Is that clear? Okay, please make a correction in your study material. Okay, so is this table clear now? The new table, second table? Second table is clear? Second table is clear? Yeah, second table is clear?
Yes, madam.
Yes. Now we will find out ZJ now. How do you find out ZJ? 1 into 8. 1 into 8 is how much?
8 plus 0.
8 plus 0, 8. Half into 8,
4
4.
plus
1
0.
by 4 into 8, 2. 0 into 8, how much? 0. 0. Now again, Zj is there. Cj minus Zj we can find out easily. 8 minus 8 is how much?
0.
0. 6 minus 4. 6 minus 4.
2.
2. 0 minus 2. 0 minus 2.
Minus 2.
Minus 2. And then again 0 minus 0.
0.
0. So is the new table clear? Yes. Now, what's the criteria? What's your objective? Maximization. Highest positive Cj minus Zj is what?
2.
2. So, which variable will be entering?
X2.
X2 will be entering. Which variable will leave? That will be decided by replacement ratio. See, you don't have to think that before S1 was replaced, now it won't be replaced. Sometimes it so happens that same variable can be replaced again. Okay? So don't be under an impression that once it is gone, it won't come again. It can come again. Okay? So please find out replacement ratio. How do you find out replacement ratio? 15 divided by half. 15 divided by the key column value. 15 divided by half is how much?
30.
30. 18 divided by 3.
6.
6. Which is the least positive value?
6.
6. So it will be leaving variable. So which variable will leave in the next table?
S2.
S2. Which variable will enter?
X2.
X2. Okay. So now tell me which is the key element?
1 by 2.
One key element.
Sorry.
The
3.
intersection of key column and key row. Which is the key column?
X2.
X2 column. Which is the key row?
S2.
S2. So the intersection of key column and key row is the key element. Key element. Is that clear? Yes. So this is your key element 3. They have already written here. Okay. Now, which is known as key row? S2 row, isn't it? Shall we find out the new key row values? Write down old key row values. These are the old key row values. Old key row values divided with key element. Please. Okay. Divided with key element. So you will get the new key row values. What are the new key row values? What are the new key row values?
Six.
Yeah, 6,
0. 0.
1, minus 1 by 6. Yeah.
1 by 3.
1 by 3. Is the new key row values clear?
Yes.
These are the new key row values. What is the key column value for the first row? Key column value?
Half.
Half, right. So what you do is multiply all the numbers with half. Multiply all the numbers with half. Yeah, multiply. Tell me.
3, 0.
3,
0. 1 by 2. Minus 1 by 12.
Very good.
1 by 6.
6. Okay, and write down the old non-key row values. First row is the non-key row value. Non-key row, isn't it?
Yes.
Yeah. So write down all those values here. Can you tell me? 15?
15, 1.
1.
1 by 2.
1 by 2.
1 by 2.
4.
0.
0. Now subtract. That will give you the new non-key row values. 15 minus 3 is how much?
12.
12. 1 minus 0?
1.
1. Half minus half? Half minus half?
0.
0. 1 by 4. Is this minus 1 by 4 or 1 by 4? Can I?
Plus 1 by 4 only.
Yeah. 1 by 4 minus of minus 1 by 12. See, 1 by 4 minus of minus means it will become plus, no? You have to subtract. Okay. So 1 by 4 minus of minus will become plus. So how much is 1 by 4 plus 1 by 12?
4 by 12, 1 by 3.
How much, sir?
1 by 3, madam.
3. 0 minus 1 by 6?
Minus 1 by 6.
Yeah. So these are the new values of the non-key row. New values of the non-key row. Okay. And here we have done new values of the key row. Okay. These are the new values of the key row, new values of the non-key row. Is it clear? Yeah, he has given here new row values, new key row values, new non-key row values. He has given here. Are we getting the same values? 12, 1, 0. Yes, we have got the same values. Okay. Now substitute in the new table. Substitute in the new table. Okay. Now see here. In the first table, from the first table, we had S1, S2. In the first table, S1 got replaced with X1. Second table, S2 got replaced with X2 along with the contributions 8 to 6. And these are the new values. We have entered the new values in the table. Okay. Again, we have to find out the ZJ value. ZJ value is quite simple. See, we have written it side by side so that multiplication becomes easy. 8 into 1 you have to do, then add 6 into 0. How much do you get?
8.
8. Okay. Then 8 into 1, 8 into 0 plus 6 into 1. How much?
6.
6. Then 8 into 1 by 3 plus 6 into minus 1 by 6. Eight by 3 minus 1. How much do you get? 8 by 3 minus 1. 5 by 3, isn't it? See, this 1 I can write it as 3 by 3. So 8 by 3 minus 3 by 3 is 5 by 3. Are you getting it? ZJ is nothing but you have to multiply this and this. You have to multiply this and this, then add. That's all. 8 into minus 1 by 6 is how much? Minus 8 by 6, isn't it? 6 into 1 by 3 is 2. Minus 8 by 6 plus 2 is how much? 2, I can write it as 12 by 6. So I'm getting 4 by 6 is nothing but 2 by 3. Are you getting it? ZJ calculation is clear? Yes.
Yes, ma'am.
Yes. Now again Cj minus Zj. These are all repetitive steps. That's all. Again and again we'll be doing the same things. Okay. Yeah. Now tell me, what is the entering variable rule? It should be maximum positive number. Do we have a maximum positive number now in Cj minus Zj? Do
No.
we have? No. Means we have got the solution. Are you getting the point? We got the solution. Yes?
Okay, ma'am. Okay.
Yes. So what is your solution? X1 is equal to 12. X2 is equal to 6 is your solution. That's all. Very
Okay.
simple. Okay. X1 is equal to 12. X2 is equal to 6. And at these values, how much is the Zj value also you need to find out. How do you find out Zj value? Again, same. 12 into 8 plus 6 into 6. How much is Zj? 12 into 8 is 96. 6 into 6 is 36. So how much is Zj? How much?
132.
32. That's all. Okay. Yes.
Yes. Yes, ma'am.
Yes. So we have to do that iterations till all the Cj minus Zj become lesser than or equal to 0. If it is a maximization problem, okay, all Cj minus Zj should become less than or equal to 0. Stop the problem. Stop the problem. You have got the solution. Where do you find the solution? Here. Okay. Yeah, you will find the solution here. This is your solution. Okay. Yes or no? Did you understand?
Yes, ma'am.
Yes. So shall we move to the next problem?
Okay, ma'am.
Okay. So now this problem, all the constraints were less than or equal to constraint. Okay. Here, can you tell me the change in the problem? See, Z is equal to, first let us change the constraints. 2x1 plus
Plus
3
3x2
s1 equal
plus
to
12.
12. Second constraint,
2x1 plus
plus
x2
x2 plus
plus
s2
s2
equal
is
to
equal to
8.
8.
Objective function also we have to introduce these new variables.
60x1
60x1
plus 70x2
plus 0s1
plus
plus
0s2.
0s2. Is that clear?
Yes, ma'am.
Yeah. So now the same thing again. See, they have entered in the table, find out Zj, find out Cj minus Zj. Then highest value will be, yes, ma'am.
Ma'am, above definite above there they mentioned that 0s1 and 0s2 na.
Huh.
Yes, there.
Yes.
2x1 plus 3x2 plus 1s1 plus 0s2.
Huh. So ma'am, yes. Need not be ma'am. Just to introduce all the variables they have given. That's all.
Okay.
0s2 is nothing but 0 only, no?
Oh, yes, yes.
Just it will become easy for you to enter here, ma'am. Here.
Okay.
Okay.
Okay, okay.
Okay, that's all. If
Okay,
you
ma'am.
omit that also doesn't matter. Okay.
Okay, ma'am.
So is it clear?
Ah,
So
yes.
here again maximization problem. See, they have done it till all the Cj minus Zj's have become lesser than or equal to 0. Are you getting the point?
Yes.
Yes. Okay. Shall I proceed further?
Yes, ma'am.
You one thing, you can imagine you going to a shop. Okay. So and they will be having a common balance, isn't it? Or vegetable vendor. So this is the common balance. Okay, I am not sure whether I will be able to draw it better or no. Okay, yeah, okay. So now I'll tell you one thing. Previously we had this part lesser. Okay, this was less, isn't it? This was more. So we added here slack variable, isn't it? Yes? Yes or no?
Yes, yes, ma'am.
Yes, but now suppose, imagine this side is more. What do you do?
Add little bit more here.
No, no. We have to do something only to the left hand side. We can't do anything to the right hand side.
Yes, ma'am.
Yeah. So what will you do on the left hand side to make this both equal? Remove, isn't it?
Yes, ma'am.
Yeah. The variable which we remove is known as surplus variable. What is it known as?
Surplus variable.
Surplus variable. But now you just imagine when we are removing something, we can't guarantee that we are removing exactly the same amount, isn't it?
Yes.
See, you just think a shopkeeper, he has put weights on one side, other side he has put some commodity. Okay. So he has added more commodity on other side. What will he do? He will remove more, then slowly he'll go on adding, isn't it?
Yes.
Can you imagine the thing?
Yes, ma'am.
So whenever we are removing the variable is not sufficient actually. Okay. Removing the variable is not sufficient. We have to add an artificial variable. We have to add an artificial variable, something like this. Is that clear?
Okay. Yes,
So
yes.
surplus variable can't be there. We have to add an artificial variable. Is that clear? So we will change here. Let us see here. Left hand side is more. So to make it equal, what am I doing? I'm removing a surplus variable. Is that clear? I'm removing.
Yes.
Yeah. But in a fear that I might have removed something more, I will add an artificial variable to make it equal. Is that clear now?
Yes, clear, ma'am.
Yes. Now, second constraint also, please tell me. x1 plus 2x2 minus
S2
plus A2 equal to
is equal to 60.
Okay. Now,
Okay.
if the objective function, see, contribution of slack and surplus, I will write down here, the contribution of slack variable and surplus variable, both are termed by S only. Okay. If you are adding, it is known as slack. If you are deducting, it is known as surplus. Difference is that. That's all. Okay. So now you tell me, artificial variable for slack or surplus, the contribution is 0. Okay, always. Okay, but artificial variable contribution is M. What is the contribution? M. M is a very big number. This is known as big M method. Okay, what is it known as?
Big M method.
M method. Okay, so if the objective is to minimize, okay, if the objective, you can see here the objective, how they have changed. 600x1 plus 500x2 plus 0s1 plus 0s2 plus ma1. Are you getting the point? Yes. If the objective is minimize, the a1 will have plus m. If the objective is maximize, it will be minus m. Is that clear? You can write down somewhere. Okay. If the objective is minimize, it will be plus m. If the objective is maximize, it will be minus m. You can remember it opposite. Okay. Minimize plus maximize minus. Is that clear? Yes. Is that clear?
Yes, ma'am.
Okay. So now, is this constraints clear now? Everything? See,
yes, ma'am.
Whenever we are deducting a surplus variable, you should add an artificial variable. Okay. Contribution of artificial variable is plus m or minus m depending on the objective. If the objective is minimization, it will be plus m. If the objective is maximization, it will be minus m. Okay. Is it clear? Can we go to the table now? See the table. Everything else is same. Everything is same. Okay. See, now which variables will enter the table? From each constraint, only one variable will enter. From each constraint, how many variables will enter? How many variables will enter? From each constraint, one variable will enter. Okay. The variable which we have added will enter. See, if you remember last problem, we have and in the first table we had surplus variables, sorry, slack variables. But here the surplus variable is deducted. So what is added? Artificial variable. So A1 will enter the first table. Can you see here? A1, 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 A2. Is it clear? Yes.
Yes, ma'am.
Okay. So for the variables which we have added only are eligible to enter. The variable which we have added are only eligible to enter. So slack can enter, artificial can enter, but surplus won't enter now. Okay. So contributions we have written here, right? X1 contribution is 600, X2 contribution is 500, S1, S2, A1, A2 we have written. Okay. We have entered all the constraints here like this. Now again, Zj we have to find out, Cj minus Zj we have to find out. So 2 into M plus 1 into M is how much? 2 into M is 2M. 1 into M is M.
1M.
2M plus M is how much?
3M.
3M. Are you finding 3M here?
Yes.
Yes. Then 1 into M, second column. 1 into M is
M.
plus 2 into M is 2M. 3M again. Isn't it?
Okay.
Then minus 1 into M is how much?
Minus M.
Minus M. 0 into M is?
0.
0. So are you seeing minus M here?
Yes, ma'am.
Yes. So find out ZJs. Find out ZJ. All ZJs we have to find out. Okay.
Okay.
After ZJ, we have to find out CJ minus ZJ. Okay. CJ is written on the top. ZJ we have found out just now. Okay. Just subtract.
Okay.
Subtract. Okay. 600 minus 3M is how much? 600 minus 3M.
600 minus 3M.
Yeah. 500 minus 3M is how much?
500 minus 3M.
0 minus of minus M.
M.
M. 0 minus of minus M.
M.
M minus M.
0.
M minus M.
0.
Oh. Okay. Now, what is your objective? Maximization or minimization?
Minimization.
Minimization. See, for maximization, the key column criteria was highest positive number, isn't it?
Yes.
Yes. Now, in this case, highest negative number.
Negative value.
Now, I'll tell you, M is nothing but a positive number. So, this is ruled out, isn't it?
Okay.
Yeah, this M is also ruled out. 0 is ruled out. 0 is ruled out. Okay. Minus 3M will enter. Minus 3M will enter. But there is a tie, isn't it?
Yes.
Yeah. Now you just imagine M to be a large positive number. Large positive number. Shall I take 1 lakh?
Okay.
Large number. Any large number. Okay. Now tell me 600 minus 3 lakhs. How much is it? 600 minus 3 lakhs. How much is it? Minus 2 lakhs. 99,400, isn't it?
400. Huh.
Yeah. Now 500 minus 3 lakhs is how much? $500 minus 3 lakhs is how much? Minus 2 lakhs, 99,500, isn't it? Yes? Yes or no? See, we are just comparing 600 minus 3M with 500 minus 3M. So, which is more least? Minus 2,99,400 or minus 2,99,500? Or you see the magnitude, which is maximum out of this. Ignore the minus sign. Which is bigger number? 2,99,500 or 400? 2,99,500 is bigger or 2,99,400 is bigger? Yes, please. I don't know what happened today. Nobody is active in the class. Which is more bigger? Yeah, this is more bigger, isn't it? 2,99,500. So this becomes the key column. This becomes the key column. Okay. And then the methodology is the same. Okay. So I will come again. Maximization problem, the entering column will be the highest positive number. For minimization problem, the key column will be highest negative number. Okay. So this becomes the key column. For the key row, the criteria is same. It is least positive number. Out of 80 and 30, 30 is the least. So it becomes the leaving variable. And the intersection of key column and key row is the key element. Here it is 2. Again, the procedure remains same. We have to find out the new key row values, new non-key row values. Again, enter it in the table. Everything remains same. Okay. Now, there are some highlights which are given in your study material to guide you better. Okay. So these are all self-explanatory problems. Actually, if you follow step by step, you can do on your own also. Okay. So they have given when do you stop the problem? When do you stop the problem? One condition is given in italics. You can see that. Okay. Maximization problem, you should stop. Yeah, here he has given. If all the Cj minus Zj is less than or equal to, stop the problem. If all Cj minus Zj's are greater than or equal to, stop the problem. Okay. So this is how you get the solution of a simplex problem. Okay. So even if it is a mixed criteria also, it doesn't matter at all. Okay. 1 minute. I'll just change the numerical and tell you mixed flow chart. Okay. Yeah, mixed constraint. Shall we take up this problem? Yeah, 1 minute. Yeah. So this becomes a mixed problem. We will see if it is equal to constraint. What do? We still add an artificial variable. Okay. We still add an artificial variable. Okay. Plus A1 equal to 150. Okay. If it is less than, add a slack variable. Okay. Slack variable. If it is greater than, remove a surplus variable and add an artificial variable. Okay, this is how we have to conduct. Is that clear? Yes. Okay, maybe tomorrow's class will solve some of these problems, or at least we will try to make the table and enter that values, and we will try to see, accommodate as many as possible, followed by rest of the problems. Okay.